Okay, so when we're taking a look here, the limit as x approaches 2, what did we get? Okay, it is 3. Tell me about that point at 3.
It's a hole.
It is a hole. So then what if I asked you to evaluate f of 2? Is that equal to 3? No. Okay, so again, this is one of those crazy piecewise functions. This is kind of irrelevant here. Okay, but, you know, this is what we see. All right, so the limit as x approaches 4.
0.
It is 0. Awesome. Okay, does anyone have any questions about these? This is 0. So what do we say? This is 3? This is 0? Okay, so example 3 I'm going to skip because, again, it's very repetitive. It's the same thing that we just did, just a different graph. So you should be able to do those if you want to do them like in the 2 seconds that I'm talking here, or you can go back and take a look. The answer key is posted on Schoology. All right, so let's talk about using the calculator. I know that some of you don't have one yet, and it's totally fine, so I'm going to show everything up here. Not a big deal. But one thing that we do need to note, and I'm only going to do one of these, is that all trig in calculus is going to be in radian mode. In radian mode. Okay, so what I'm actually going to do is example 4. Example 5, you guys can work on together, or if someone has a calculator that you guys can work on and look at each other, that's totally fine. But what we want to do is use a table and a graph to estimate this value. So first of all, let me just talk about limits. We will talk about how we evaluate them algebraically, but our ultimate goal is to be able to evaluate these functions by using direct substitution. That's what we've been doing since, I don't know, middle school, maybe part of elementary school, where you have a value of x, and you have a function that has x in it, and you plug in that x value. That's what we want to do, because it's easy, right? Plug and chug. We're good at that. All of us are. But there are some occasions when that doesn't work. And if you take a look here, even though I'm asking you to use a table, if I didn't ask you for that, and I said, okay, evaluate this limit, what's the sign of 0?
0.
Okay, it's 0. And then when I plug in 0 in the denominator, not only can we not divide by 0, but does anyone from last year remember what 0 over 0 really is called? I know I said it. This is probably something you might not remember, and we're going to talk about it a lot. It's the same thing as like infinity over infinity, negative infinity over negative infinity. It's called indeterminate, meaning you can't figure out what's going to happen. So that's why we need to take a look at what is the behavior, which is what a limit is, from the left and from the right, which is why we have this table. So now we just know here, this will give us an error message, or this just is, it doesn't exist. It's undefined, right? Indeterminate. So what we're going to do is use this table. So for those of us that have forgotten, I went through this the other day, but we're going to go into our calculator, and I'm going to put this function in, and I want it to look exactly like what it looks like on my paper. Okay, so we have the sine of x over x. Okay, so it is in alpha y equals. If you don't have that menu, we can download it. It's no big deal. Okay, and then remember, we want to change our table setup. So mine is still stuck as ask from yesterday and the day before. Okay, but I went into second window, so I can change this from auto to ask. I go into this table. I have all these weird values, so I'm going to delete these so that it's blank. Okay? And now we're going to plug these in. So negative 0.1, negative 0.01, and I'm just getting these from the table. Negative 0.001. I'm not going to put in 0 because I know it doesn't work. So we've got 0.001, 0.01, 0.1. Okay, so here I am approaching from the left. This is actually kind of far away, even though it doesn't seem like it. So I'm going to write down these values. So this is 0.99833, 0.99, ooh, is there 4 nines there? And this one looks like it's 1, but remember what I said about hovering over it? Yikes. Okay, essentially, does everyone see why they rounded to 1? And when I say they, it's the program and the calculator. There's no people in there. Okay. All right, so we've got 0.9246. So 2, 4, 6, 8, 3, and I'm just going to say repeating, which is approximately 1. And then if you look at the other side, it's identical, right? So this is 1, 2, 3, 4, 5, 6, 8, 3, and I'm going to say repeating, approximately 1. Here I'm just kind of exaggerating to make a point. Basically, you would fill in the table, so here you might say it's 1. You would probably put that, just because this is just so crazy. But again, for your notes, I'm just making a point. Okay? So probably, since the table ends, you could put these in. This one I would say approximately 1, because this isn't too long. But it's just to see what is the trend. So if I asked you to use the table, and we'll look at the graph in just a second, to estimate this, what would you say the value is? It is 1, because we're approaching from both sides. Let me see if nope. Zoom 6. See if I can get this graph. All right. So I graphed this by hitting Zoom 6. Okay. I'm just going to show you a couple features that you can do, and then I'll give you a couple minutes to work on this table. But you guys know you can zoom box, meaning if I go zoom and I want this option 2, for those of you that haven't seen it, you can barely see it, but my cursor's right there. I want to box in this area. Why? Just because I want to see what it looks like, and so I can demonstrate this. So here's where I want this box to start. So I'm going to press enter. If I move this down like this and over in this direction, I'm using my left and right arrow keys here. What's up? They're at the front. I'm going to press enter. Okay, so the limit as x is approaching 0. You guys can see it. Now, if I went into a regular standard table of values at 0, it's going to be undefined. It's going to say error. Oh. See, error. But we already knew that because we did the calculations in our head. Okay, so again, I'm back at the graph, and I'm just proving it by the graph. I'm backing myself up. Okay, questions about, again, we will go more through the calculator. I know we need to practice. It's been a really long time. But questions about how we got these values. Worst case scenario, if you don't have a graphing calculator right now, you would just put this in, and you'd have to plug in these values and calculate. Okay, remember, you do need to make sure you're in radian mode. One thing that I do want to warn you about when you work on the next question, which I'm going to let you do in just a second, some of us will see the pattern. Some of us might not. So we might need to confirm with the graph. Okay, so I'm going to give you just a couple minutes to do this. You can go in and do the same thing, and then we will check our answer.